Hey everybody, uh, welcome to Cassandra Lunch number 27. It's actually 11/11 today. Um, Today we're going to be discussing Cassandra on Baremetal versus virtual machines versus containers. It doesn't really matter, everything's on the cloud these days. And this is one of the topics that was requested in previous Cassandra Lunch. Aki, thanks for organizing, helping organize this meeting. Always looking for people to organize, so please reach out. We're part of Data Community DC, which is a much larger effort than Cassandra Lunch or any of the other meetups that we work on. It's a made up of several meetups, mainly around data. This Night Owls is actually a group that just meets late night to work on side hustles and moonlight projects. I don't know how they do that in Zoom land, but they used to get together at co-working spots. What do we cover? We cover stuff around Cassandra. Cassandra as a database has been implemented. The protocol has been implemented. Over the course of the last 10 or so years, there's different variants of Cassandra. And so we will cover, we have been mostly talking about Cassandra or DataStax, but we will cover maybe Alessandra, Skilla, Yugabyte. Nobody new today, but if you have a question, just reach out in the chat. Shout out to DataStax, GW, George Washington University, our local sponsors, and our institutional sponsors. Quick announcements. Cassandra.Lunch, everything here is posted online on YouTube. Just Google Cassandra Lunch. Cassandra.Link, it's actually going through some amazing improvements. In fact, we can take a quick look and see. And as we add more resources, more will be added to the navigation. And then we're working on continuing to improve our jobs aggregator for all things Cassandra. And if you have any questions, if you want to help with the project, you can also reach out. I'm actually going to put this screenshot, if it will allow me. No, it won't allow me. Anyways, we'll do that later. Okay, we have some events coming up in the following weeks. Packed schedule all the way to the end of the month. There's a talk on how to use Apache Spark with DataStax Astra. And DataStax Astra is a hosted Cassandra as a service, which DataStax Astra does not have Spark. DataStax Enterprise does. So anyway, that's what it's talking about. Spark Companion notebooks, how to use the different types of notebooks with Spark. Running a Spark job against a DataStax Astra cluster, and then something a little bit lower key, but it's still a very important topic, is counting or aggregating things in DataStax Enterprise with or without Spark. Okay. All right, so let's get right to it. There's a lot of different ways to deploy Cassandra, namely because there's a lot of different hardware out there. Because it's Cassandra is open source, the features, basically, distributed database, multi-data center, topology, masterless, masterless architecture, allows us actually to run Cassandra on one or two or three different types of hardware if we wanted to, given enough effort, or one or two or three different clouds if we wanted to, given enough effort, or a combination of that. And the terminology, basically, the deployment terminology that we use is, is it bare metal, which we'll talk about, right? All hardware in a data center. Also, generally, somebody could say it's a private cloud, but this is not really a private cloud. It's hardware. Private cloud would mean that there's virtual machines, right? We have virtual machines. Or actually, you know what? There's a company that actually offers public clouds with bare metal. I forget. I think it's called like Packet or something. Yeah, in fact, that's what it is. Packet.com. Now acquired by Equinix. Equinix is, wow. Yeah, they're probably one of the better carrier neutral data centers out there. It's kind of interesting now they're in this business, but basically you say you want a bare metal machine, they'll make it for you. But you can also obviously use things like rack space, right? There's still companies out there. I've been in the hosting industry for 22 years. Or actually more than that. I understand the hosting industry since then, at least. There's still companies out there that you pay a certain amount of money, they'll give you a physical machine, right? So you can still do that without maintaining your own hardware. So then the next layer, which is most people today, when they're working with something like Cassandra, will go into essentially Amazon, right? So public clouds primarily. We have our AWS, Azure, Google, we use DigitalOcean to play around with things. But you can also do virtual machines on VMware. It's called OpenShift. OpenShift is a container platform. One second. Everything is open something. What is DataStax? There. OpenStack. And then you name it, every hardware company has bought some software company that allows you to do some sort of private cloud. But essentially, these are some of the most common ones. And then the bleeding edge is containers, people doing things on containers. Containers are different in nature than any of these because they are, by nature, they're immutable. They're not necessarily off the start deployed in a way in which you make modifications to data and have it persist. And unless you configure your whatever your container orchestration system is to properly manage that data somewhere, because the container itself is ephemeral, you may lose the data. So you have to be careful. It's getting easier and easier, but at the core, Docker, the Docker daemon itself, you could run one Docker container of Cassandra on one virtual machine or on one bare metal. In fact, there's a talk by Instacluster in their early days. They were talking about how they started to use, now they're mostly, I think they use Kubernetes, but how they standardized all of their images to work with Docker. And because all of their hardware had Docker on it, they just have to make images for their different versions of Cassandra. And since Docker is a standard, no matter where that Docker was installed, they were able to deploy Cassandra 2, 3, 4 consistently. And if anything happened, everything was weird, they would just roll back that container and they would bring back the older container. So Docker itself, when I say just the Docker daemon, that's one way to do it. The other is to use something called Docker Compose, which basically manages your Docker daemon and runs other things around it. So again, why would you use Docker Compose and not just Docker? Well, if you want to have Cassandra, a Cassandra sidecar like Medusa and a Cassandra sidecar like Reaper, maybe you want to have you know, an API layer co-located with it. Maybe you want to have Spark co-located with it. Docker Compose, at the very core, without Docker Swarm, allows you to orchestrate multiple things at the same time. And that could be useful. But these days, this is really just used for local, you know, local development. And you may even use Minikube, which is basically Kubernetes. It's actually distributed with Docker for Windows and for Mac. So if you go and download the Docker desktop, whatever they call it, it'll have Kubernetes in it. So you can actually play with Kubernetes, and that's really the process as people get into it. Who else? Okay, so yes, Kubernetes. We'll come to Kubernetes, but somewhere in the middle, people use Mesos, and more specifically DCOS, not really Mesos, but DCOS, which the commercial version is called Mesosphere, and I think they changed their company name, so I don't know who they are these days, but Mesos is the granddaddy of all containerizing technology. It's been around way before Docker. And I'm not going to get into the history of Docker and containerization, but a lot of the Silicon Valley companies, when they have to run a very, very, very large application, they would make sure that it is deployed on Mesos, because what Mesos does is it takes lots of hardware, makes it into one massive computer, and then when you start executing your things on there using things like, you know, Marathon, for example, it distributes it and gets it done. They have concepts that are very similar to pods and in Kubernetes, but I used to be a big fan. Their interface was amazing, is amazing. DCOS also has Kubernetes on it because, you know, any application can run on Mesos, and so you end up with Docker, right? You don't have to Dockerize an app to work on Kubernetes. You can use other containerization technologies. I'm not going to get into them. There are, because of the OCI, Open Container Initiative, Docker set the standard, and everybody else can create OCI compliant images that run on Kubernetes or Docker or anything else. Finally, we're at Kubernetes. So Kubernetes is the winner of the distributed computing orchestration war, because Kubernetes, not only is it available to you on your own Baremetal if you install it, you can install it yourself on your public or private virtual machine cloud, or you can get it as a managed service on any of these. So I'm actually just going to make another thing called Kubernetes. Okay, so Kubernetes you can do on Baremetal. You can do it on virtual machines, right? Public, private. And you can do it on public or private Baremetal, and then cloud. Well, we just talked about cloud. So this right here, it's interesting that we say that Kubernetes can run on Baremetal, public, private, virtual machines, public and private. Kubernetes can also span, given it enough effort, different types of hardware, different clouds. Hardware on Baremetal, on a public or private cloud, and public cloud virtual machines. Does that remind you of something? Right? So Kubernetes shares that. It can run on different hardware, in the same way that Cassandra can run on different hardware. So it is actually a pretty good technology to conform to in terms of if you want to containerize Cassandra, you might as well use what everybody else is using. In fact, I wrote a article. Did everybody lose me? You guys see my screen?
Yes, okay.
Okay. Sorry, I lost my screen for a second. Sorry. Okay. So there we go. This is not what I want. Why is this not coming over here? Well, Chrome is consistently giving me the middle finger. So what I'm going to do is I'm going to kill Chrome. And I'm going to switch over to Edge. Because, you know, actually Edge is not a bad website browser. So let's see. And, you know, that allows us to think about, you know, a couple of different things. We can run Kubernetes, let's say, on one data center in one cluster, or we can run Kubernetes on two different data centers, same cluster. But where this data center is, it could be on AWS, whereas this is on Azure. This is not easy to accomplish with multi-cloud. Well, I'll just say that I know plenty of people that go into this and they think it's easy. It's not. There's a lot of things related to the way Cassandra works on Kubernetes that is not apparent. But Kubernetes, I'm going to talk more about it, and we'll talk enough about it, but we're not going to go into the reasons why it would be great. But there's a lot of different operators for Kubernetes now. It's getting to be mature. There's no production support for Cassandra on Kubernetes, except if you go through one of the managed service providers, basically. DataStax Astra is one of those, and Instaclustr would be the other one. I think maybe Ivan also does use it. So these are the deployment strategies for not just obviously Cassandra, but for Kubernetes or anything. Reason I went through this is that when we go into these different strategies, we can also look and compare between bare metal and virtual machines or containers. You know, why would we do that? Why would we use it? And is there a way to make this easier for us? So also Docker. So bare metal, generally people have to go and manually make these computers, build them, buy them, configure them with an operating system. Even with net boot, you can basically say when a computer comes online, install its operating system. Even with all of that, eventually, provisioning bare metal is, unless you're an advanced cloud company or a fairly advanced tech office or a data office, you don't have the same wherewithal, but it's getting easier. Terraform, which is an infrastructure as code software, it actually has a provider for Metal called Metal Cloud, which will make it a little bit easier. But when you're deploying to bare metal, you get the benefits of basically, let's just say, pros, right? We'll do the pros first. The pros is fast, right? It's on the hardware. It's as close as you can get. Cons, it's difficult to deal with, kind of. Not necessarily, right? If you get a machine provisioned for you via packet, or you buy it from some hosting company, you get dedicated servers. Once you have the computer, if you were to use Ansible to install all of your prerequisites and install Cassandra or DataStax on it, after that point, it doesn't really matter. Because the bare metal is just running Cassandra for you. Ansible is basically going to be managing the operating system and doing rolling restarts and things like that. If you have automation in your blood, if you have automation in your thought from the very beginning, bare metal actually is not that much different than private cloud or public cloud. Because once the hardware is provisioned, you can basically let Ansible do the rest. Alternatively, if you have the Docker daemon installed on bare metal, you can use the Docker command to run containers on each of the nodes remotely. You can just say, this is my new Docker host, run Docker. Go to the next one, run Docker. And anyways, that's one of the ways to do it. But I think that if you're, in using Docker, you don't lose, there's no layer in Docker. Docker just contains the application. There's no hypervisor between Docker and the hardware and the operating system that's running on the hardware. There's ways to do what's called secure Docker on Windows or whatever, where it basically wraps it with a hypervisor. That's not what I'm talking about. So you don't lose anything by running Docker on bare metal. It's the same. Next would be virtual machines. Let's say your pros are virtual machines on the cloud. Excuse me. Your pros here are that you own the hardware. It's great. Can do basically what you can do with public cloud, right? As long as you have the permissions to provision yourself machines, it's not that much different. In fact, there is a Terraform provider for VMware in which once you connect to the ESX server, you can say, I want a new computer, and it'll make a new computer for you, and it'll give you the IP address. And after that point, Ansible, or as we discussed, Docker can be used to then start Cassandra on that hardware. As with bare metal, once you have the hardware provisioned, either manually or via Terraform, doing the rest on Ansible is actually the same. This step is the exact same as if you had bare metal, because Ansible doesn't care. It's doing SSH operations on that machine, and Cassandra doesn't care. Cassandra just saying, I want Linux, I want Java. As long as those are, installed, it will run. Or if you have Docker, Docker has all the prerequisites. Docker just says, I need Docker, and it'll pull down the public image, and then it'll run your container for you. Public cloud, which is what most people these days, if they are experimenting with Cassandra, I doubt somebody's going to go and buy a computer and install it. Some people do. We have machines in the office. We like to mess around with computers. It's cheap, right? If you buy a computer these days, it's like $300. You can get it with like 16 to 24 gigs of RAM with SSD. That's your year. That's like, I would say, like 6 months hosting bill for the computer of a similar setup. And after a year, it's $600. And so if you're just playing around, maybe that's what you do, right? You just get a computer, get 3 computers for $300, and you play around with it. And it'll have some juice if you're on the economic track. But public clouds are, the biggest pros are easy to create, destroy computers. The biggest thing is really charged by use, right? So if you're not using the computer, you turn it off, they don't charge you. To a certain degree. for example, DigitalOcean, even if you stop the computer, they're still charging you, so it doesn't really make a difference on that cloud provider. But the rest of the cloud providers, you're only going to get charged for your use. The other pros are that there are APIs. And technically, oh, I didn't do the cons for this. I'll come back to this. The cons for private cloud are, your hardware breaks. Right? You're screwed because, it's your hardware. There's no magic pool of hardware that is coming and helping you with this. And the same thing with, I would say, if you're doing, Baremetal by yourself. There are APIs in the private cloud that you can use. In fact, if you were to use OpenStack, OpenStack has the same API layer, I believe, as AWS to create machines and block storage and everything else. But definitely in the public cloud, you get APIs to do things. You also get amazing backup scenarios. But the biggest one is massively available cloud storage, which is helpful here. Massive block storage drives, which basically are very fast drives that you can attach from one computer to the other. And in Cassandra, that's actually the fastest way to recover a cluster. You could lose all of your hardware, but if you're using, let's say, EBS volumes on Amazon and you've snapshotted them, you could restore those EBS volumes with new computers, with new IP addresses, and just go to the configuration in the JVM options and say, I want to replace this old IP address with this new one, and the cluster will come up and it will work exactly the same way it did minutes before you lost the hardware. That you could probably get by and do on your private cloud. Kind of hard here. Again, it's possible, but kind of hard. You really have to be a big tech operator yourself. But this is one of the best features of using the cloud is your backup scenario is way better than if you were doing anything on your own. And yeah, Cassandra is a multi-data center and it's all DR ready, disaster recovery, really disaster avoidance ready. But sometimes people delete data. How do you get it back? Or sometimes hardware goes bad. The computer shuts down. If you have your data on block storage drives, volumes, you don't have to stream data in from the other machines. So you're even though the cluster is up and running, even though it's if you have like a big 1,000-node cluster, like one node going down is nothing, but it's still in a degraded state, quote unquote, because technically one replica of essentially, if you have replication factor is 3, one replica out of 3 is down for some partitions. So when it's down and you haven't removed it or essentially decommissioned it or assassinated it, potentially people do all consistency level queries are going to fail. So how long is that happening for? Well, you can manage that if you have it, EBS volumes or whatever the equivalent is on Azure. Bring up a new machine, attach the drive. You could even automate the process of, hey, detect my IP address, and the first time that I come up, say replace IP with this thing, and the next time I come up, take that line out. You can automate all that, and basically within 5 to 10 minutes, which takes. The reason it would take that long is, because you're restoring from a snapshot, but also takes time for the commit log to be replayed if the commit log is also stored on that same drive. Cons, Cons are, I don't know, very few. Some people complain about costs. You know, if you go into a Mercedes dealership and you say that it's expensive, you're not in the right store, right? Cloud is not cheap. It's never supposed to be cheap. It's supposed to be pay per use. So if you're going to start storing terabytes of data with lots of transactions happening and have the ease of the cloud, you are paying for it. But where you're saving is managing the hardware and the orchestration of the hardware and the network, and I mean, you name it, right? You're saving money because you are not doing all that yourself. But the reason people think that it gets expensive is because they're comparing just the hardware cost versus the hardware cost. And that's not the reality. It's actually hardware plus maintenance generally can be much more expensive than this. There is a break-even point, however, where at the amount of hardware you have, if you have orchestrated it and managed it properly with automations, the right amount of labor could actually end up being, this is actually cheaper on a holistic level. And we're talking like thousands of computers, or maybe even 100 computers. I know several companies that have public cloud infrastructure for some things, but for data heavy needs like Cassandra or even Elasticsearch, they do it in their own private data center. Because heck, $300 computers, man. you buy. So like, let's consider the Azure pricing calculator, right? And let's say I want a 30 node cluster, and let's see, even if we do 3 years reserved, let's say, okay, fine, I'll just say upfront, right? No license, I don't need the license, I just need Linux, Ubuntu, yeah, tier, okay. I'm gonna definitely want 16 CPUs. Yeah, 64 gigs should be okay. And I want 30 of them. It's $9,000 a month. That's $300,000. But if I go for 16 CPU, 64 GB, mid tower, okay. I'll just say this, okay? It doesn't have to be this. It could, I mean, really, we could get like, rack servers. But let's see if this has it. This even has Windows 10. I don't even need Windows 10. Here, Amazon will probably give me no BS here. 6 core, let's say, I'll do Dell. Nobody's sponsoring us, by the way. I like Dell. 64 GB, the 2 terabytes, and we'll do some late. Oh, okay, these are kind of like the bleeding edge. But even then, let's just say this is $2,500. Okay, $2,500 and times 30 is $75,000. And then you're going to pay for electricity and stuff. So let's just say an extra $500, even if it's $1,000, is a pretty big, right? $1,000 times 36 months. So 36,000. Oh, okay, internet costs. Fine. Good internet, $500. That's another 36,000. Okay, so 72,000 times 70, plus 75,000, and you have basically $150,000 bill for that same hardware and the hosting and the electricity. And I'm like overestimating here versus this. And this does not include things like bandwidth and things like that. That could be more expensive. Oh, and this is only 600 GB. So actually, if we did something like with more storage, like we have 2 terabytes in there in that one. Unfortunately, it's kind of like scaled. So that would be way more expensive, right? So we're talking about way bigger disks for $150,000 or $300,000. And actually, you know, you can continue to compare, but eventually you have to ask the question, do you want the ability to create and destroy machines and scale up and scale down the cluster, or you don't care? You're happy to buy a new computer if the thing fails, or replace hard disks and cut up your hands with a motherboard. Which, as I said, I've been in hosting a long time ago, and that's what you do with hardware. You build hardware sometimes when it breaks. Like, you really want to do that. So the other thing about, as I said, some people complain about cost. The other issue is bad hardware. Because you're using public hardware, some hardware goes bad. SSD drives go bad over time. So you have to basically restart. You have to create a new instance sometimes, because the hardware that you're on is bad. And so you have to deal with it. You have to manage it. Terraform is obviously one of the ways to do this, but they also have so many integrations. So many integrations here. Probably even have, monitoring and alerts, you name it. There's a lot of stuff you get with the public cloud. That's why it costs money, right? And finally, containers. So everything I just said about virtual machines and bare metal for Cassandra applies here, because you can basically do the same thing as long as the hardware is installed and it has Kubernetes on it. It doesn't matter if you're using virtual machines or bare metal or virtual machines on public or private. So similar to Ansible being able to do everything for you, installing Cassandra, once you install Kubernetes, essentially your Docker container is doing stuff, and you're going to use Kubernetes to start and stop containers and expand and contract data centers. But that's still not the complete picture. You can create let's say Azure Kubernetes service, which is their managed service. So you don't have to create machines and install Kubernetes, right? You can say install a cluster. I think TK actually did a presentation on this. It's somewhere on our YouTube. Install a cluster on EKS, Elastic Kubernetes Service. And once that Kubernetes service is up, you're just doing Kubernetes commands from your computer to create and run services like Cassandra and Cassandra sidecars like Medusa and Reaper, or even there's like the DataStax metrics service, for example. All of that, you're going to be using kubectl commands. And what is Kubernetes doing? Well, it's really just running a container for you. Still, even though that's amazing, create a cluster with Terraform, run this Kubernetes service YAML to start my cluster. Boom, you have a cluster up and running. Amazing. You can actually still use the same Ansible commands that are here to do your maintenance on each of those container instances of Cassandra. How? Because Ansible just needs SSH access or shell access. And you can route all of the commands that Ansibles are going to run through kubectl exec or even Docker exec. It can go and do those things for you. In fact, many folks I know use Kubernetes to bring the system up, and they apply certain things using Kubernetes apply, kubectl apply, but things like gracefully stopping Cassandra before removing the node, they'll end up using Ansible to do it because it's familiar. It's familiar against all of the hardware. So pros and cons. Pros are fast. I want 100 containers. If you have hardware provisioned, 100 containers are going to come up very fast. It's easy to upgrade. You don't like Cassandra 3.11? Take a backup of your data. Stop Cassandra 3.11. Start Cassandra 4.0. As long as you don't run upgrade SS tables, it'll work, or you can then go back. So, but that's all automated. So containers make it possible to run Cassandra with just this. The idea is that the binary is in the image and the data and the configs are on the host machine, right? That's basically what's happening. And then in Kubernetes, you have these, your configurations are stored in these YAML files. They get applied to the underlying storage engine for Kubernetes, which is etcd. And then etcd publishes that information to all of the nodes. And those nodes are assigned these persistent volume claims. And the persistent volume claims are where your data is. So if you have your persistent volume claims backed and managed by one of these cloud providers, you can be assured that that data is not going to go anywhere. But the thing that comes up is that you need to know which PVs are with which pods. Because you may be in a situation where you have to destroy all of the containers and then start fresh. And if you start the wrong configuration of Cassandra containers with one set of data, the wrong set of data, it's the same as if you brought up a Cassandra node on Baremetal and the config set one IP address, and because the data is associated with another IP address, if you don't configure it properly, it may have an issue. So again, a lot of these things are getting worked out in the community, but the other con is that everything is behind the kubectl command. And if you're used to just SSHing in and doing multi-SSH against many different nodes in a cluster, that's not as easy. You have to work around those things. But honestly, I don't even think you should be worrying about it. If you're doing Kubernetes properly with Cassandra, you really shouldn't have to do that. Your Ansible should be used, or your control, your kubectl commands or your Ansible commands should be doing all that for you. So we talked about different, terminologies: Baremetal, virtual machines, containers. And what we saw is that Cassandra can work on these different things, and Cassandra can work on multiple of these things, and it can work on multiple clouds the same way Kubernetes can do the same. And that's what makes Kubernetes a good tool to consider. However, if you're starting off, if you have 3 computers, that's a great way to start off. You'll have basically no hosting costs. Or if you have enough hardware, do a virtual private cloud, a virtual machine, on your private cloud. Easy. But more than likely, you're going to be here in this ball game of public cloud. And it's really easy to just use Terraform to create 3-4 computers, use Ansible to install Cassandra, and then you start using it. This is a pro level thing. Running Cassandra on Kubernetes and well, Docker, I wouldn't say is as hard, but running Cassandra on Kubernetes is not something that's like super easy to do. And just to kind of give you a preview of what I'm talking about here, I believe here, I'll bring it up. I'll bring up the outline of a blog post that I'm working on, just so you understand like how much is involved to get up to speed sometimes. Interesting.
Quick question while you're getting that up. Between the big three public clouds, AWS, Azure, and Google Cloud, is there one that you tend to have as your go-to, or you feel like is better than the others in terms of, particularly in regard to Cassandra? But is there any big difference between them at this point?
It's a good question. I don't think it's really, I don't really care. I'm at that point in my career where like, this is just a religious conversation about which cloud is better, for this. It's about your comfort level, right? And if your comfort level is high with Azure or AWS or Google Cloud, that's what you use. That's one. The other choice that happens commonly is the choice is made for you. The client, the platform owner, basically is using Azure for corporate IT, and they're using AWS for digital IT. And so if the application is going to be for internal, corporate needs, it may go in Azure. Even if the company has AWS, you'll be given that decision made for you. Another reason why you may use something is the vendor, AWS, Azure, or Google Cloud, in order to take away business from the other cloud providers, is giving a sweetheart deal or a lot of free credits to use. So even if 90% of the infrastructure or 100% of the infrastructure is on AWS, they may go and talk to the platform owner you're working on, the platform owner for the platform you're working on, and they say, hey, Google Cloud is happy to give you a bunch of credits for 3 years. Just play with it. So why wouldn't you use that, right? So that's one perspective. The other perspective, which I used to have, was which interface is better. I don't like any of them. They all are so wildly different now that every single time, not just wildly different from each other, every time I log in, it's like a different interface. But I think I liked Azure's interface. I still kind of like it. But it's like a database manager, you really have to use it like a pro tool. In fact, there are places in which, in order to use things, you have to really know their graph query language to query the graph of your resources. So it's like a pro tool. AWS is okay. Google Cloud is okay. I mean, everybody's trying to differentiate themselves. Honestly, I don't really care. For playing around, I love DigitalOcean. It's easy. That's the only reason I like it. It's just keep it simple, stupid. You press a button, you get a computer. Done. The choices are limited. But for production, it all depends on who the platform owner is. And quite frankly, if there's a Terraform provider, who cares? You're not even using the interface to create those machines, right? You're using a command line to say, I want computers, right? Here. Does that answer your question?
Yeah, that's helpful.
Right, so look at these different cloud providers that are available, including this Baremetal provider, Packet or OpenStack. And here's Metal Cloud, right, for your own hardware. Okay. I believe we talked about, okay, well, we're at the top of the hour in a minute. We can continue this conversation about hybrid architectures and what that looks like, and why, why would you need it, or multi-cloud architectures and what would that look like. But hopefully this gives you an understanding, like, it's not that much different. If you're using the right tools, it's about the same. It's just a matter of thinking ahead and saying, let's think about what our job is going to look like if we're here versus here. That's all. All right. All right, everybody. Thanks for joining, and don't forget to take a look at Cassandra.Link or Google Cassandra Lunch to find previous videos. Looking forward to next week. See you around. Take care.